Welcome to this video on the fundamentals of dual-clutch gearboxes. This training session covers the core principles, operation, and maintenance of DCT technology. This video is organized into 9 chapters, guiding you through the evolution, architecture, and common failure modes of dual-clutch systems, finishing with an assessment quiz. In this first chapter, we will define what a dual-clutch transmission is, examine why it was developed, and compare it to traditional manual and automatic transmissions. A dual-clutch transmission is an automated manual gearbox. It uses 2 independent clutches to enable uninterrupted torque delivery. The first mass production adoption was the 2003 VW Golf R32. Next, we will cover the fundamentals of gearbox operation to establish the core concepts required to understand how DCTs function. Understanding DCTs requires a grasp of general principles. Both manual and DCT gearboxes use helical gears, synchronizers, and shift forks to manage torque, speed, and prevent grinding. In this chapter, we will explore the architecture of dual-clutch systems, including the major components and the differences between wet and dry clutch setups. Modern DCTs are complex, incorporating mechanical and electro-hydraulic subsystems. We distinguish between wet clutches, which use oil for cooling, and dry clutches, which rely on air cooling. The design choice between a dry and a wet clutch significantly impacts how a transmission handles heat and torque in various driving conditions. Dry clutches use a pressure plate for direct high-friction engagement with passive cooling. Wet clutches use a sandwich of plates submerged in oil to absorb heat, allowing for longer slippage. This table outlines the trade-offs. Dry clutches offer efficiency and lower costs but may overheat, while wet clutches provide superior cooling and durability at the cost of complexity. Selecting the correct clutch type depends on the intended vehicle application, specifically balancing the need for heat dissipation against manufacturing and maintenance constraints. Regular service and diagnostics are essential, as the choice between a dry or wet clutch system dictates the specific maintenance needs and potential failure points for technicians. In summary, the DSG gearbox and its dual clutch pack represent a sophisticated intersection of mechanical engineering and automated control, providing efficient, rapid gear changes. Moving on to how a dual-clutch gearbox works, we examine the mechanical and electro-hydraulic subsystems that enable its operation. Key components include the dual-clutch system, the shaft-tooth gear system, and the mechatronics unit. While wet clutches use oil to dissipate heat, dry clutches rely on air cooling. Here we see the intricate arrangement of gears and shifting mechanisms that allow the gearbox to transition between ratios seamlessly. For context, it is helpful to contrast the dual-clutch architecture with conventional automatic transmissions and CVTs, which operate on different power transmission principles. This section covers the electronic and hydraulic control systems, which act as the brain of the dual-clutch transmission. The mechatronic unit manages clutch pressures and gear selection via solenoid-controlled circuits. It constantly monitors speed, temperature, and torque to ensure optimal performance and durability. The following video demonstration provides a closer look at the operation of standard automatic gearboxes. In this chapter, we will discuss the core advantages and limitations of modern DCT technology. Advantages include ultra-fast shifts, no torque interruption, and superior fuel efficiency. However, limitations involve heat sensitivity in dry systems and the complexity of diagnosing the mechatronic unit. Now, we will review the common failure modes and the diagnostic procedures used to address issues in these systems. Failures often stem from clutch overheating, gear wear, or solenoid valve issues. Technicians use diagnostic tools to interpret sensor data and perform necessary hydraulic pressure testing. The final chapter covers essential maintenance, service, and best practices to ensure longevity. Routine maintenance for wet systems includes fluid and filter changes. For all DCTs, regular software updates and clutch adaptation resets are critical for maintaining smooth and reliable operation. We have now reached the assessment portion of this video. The following questions will test your knowledge on the key concepts covered throughout the training. Let's review 2 key questions. First, the primary advantage of a dual-clutch transmission is its ability to perform fast, nearly seamless gear shifts. Second, the mechatronics unit acts as the essential electronic hydraulic control center for gear selection and clutch management. Regarding wet and dry systems, wet clutches use oil for cooling to handle higher torque. Additionally, the dual-clutch design allows for pre-selecting the next gear because it utilizes 2 independent input shafts connected to separate clutches.
Thank you for watching the training material.